How you doing, everybody? Randy Richard in the shop. Clausing update. Making the cross shaft, cross slide lead screw, shaft, whatever you want to call it. Cross slide screw. This is a 10 pitch ACME left hand thread. The rest is basic turning. This gear is independent, and I have a gear for that to put on, and there's a sleeve here. We'll make a sleeve to put in here. This is on there. I could not get this off. Anyway, I'm going to start this project, and I always like to, if I can do the hardest thing first and get that out of the way, that way if I scrap it, I only scrap part of it, maybe, you know. This is about 21 inches long. This is under 21. We have just about almost 10 inches of thread here to do. So we'll be starting at this end, turning normal counterclockwise direction this way, right? When you look at the lathe chuck, that's the direction it's turning. It's counterclockwise. You always look at the end of the shaft to tell that. So counterclockwise, and we're using a follow rest to counteract any springing action or push off of the stock as we cut this. My tool is set so that it is just a little bit, not even a half an inch, less than half an inch, maybe 3/8 of an inch to the right side of the steady rest contact. So when I get down to this far end, the steady rest won't come off, but the tool will come off the work, and I can stop and then come on back. At this end, it will come off because I've already cut this part down. This part here is supposed to be cut down to a half an inch, and we're already cut down to a half an inch. So that gives us our thread relief kind of thing for starting, which is kind of nice. Anyway, I just wanted to show you that. Now, what I did is setting this rod is pretty darn straight. This is a 4140 pre-hardened ground rod, so it's pretty straight. And what I did is I put a dial indicator against it in both directions to set these screws to make sure I'm not pushing the material down or into the tool. So we have less than a thousandth, actually less than half a thousandth even on the lengthwise of pushing into the tool. That's the more critical one because that's going to control the depth. So we're real good there, and we're pretty much ready to cut here. I'm ready to do a spring cut, or just a scratch pass, I should say. We'll just do a scratch, and then we'll check our threads, and we should be ready to go. You can see how the offset is there, zoomed in. We'll just do a couple inches worth, and then we'll measure it. Let's put a scale up here. Pick a cut, and it's even at 1 inch. But let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. We're right on the money. Put a little lube on there just to make the rest slide easier. Those were each 5/1000th depth of cuts. I'm up to 40 thousandths. Have to go to 60, and I'm going to do a spring pass here to see how we are. Not too much coming off. I can give you an idea how much springiness you have in your material. If you take off a lot, you're getting a lot of spring. So I've stopped and just looking at it, right in this area here where it kept getting a little chatter. It's just at the bottom. The chatter was right at the bottom of the root of the thread. All this rest looks good. I'll clean it up. It's got some sharp, of course, a little bit sharpness to it. Since I'm making a new nut also for this, I could still make things match just right. That's why I'm going to the numbers on this thread. So we're good. We'll just do a little cleanup and continue on with this. Now we're ready to cut where the gear goes. This is going to be the largest diameter here. We're going to make it 0.520. We'll bore the gear to fit on there. Then from here out will be basically a ½ inch all the way out. So just a little bit bigger, so it makes the gear slip on down, and then it will go fit right there. It's a little under an inch, or about an inch worth of distance. I marked it off from the old shaft on the surface plate, and that's how to get this dimension. This is a critical dimension from the far end, since we have all this finished already. And there's the radius on the end here. I just used a high-speed steel radius ground tool to do that. So we'll get the rest of this finished up. We're turning 870 RPM here. DMMG insert with a small radius on it. It should be a 431 insert. Good finish, but kind of getting a stringy chip here. This insert's kind of a hard insert to get a chip made with, but I don't have to take off very much, so. Doubled the feed rate, about 10 thousandths or so here. A lot better chip breaking. Still a good finish though. Whoops. I was going for 520. That'll be good for turning wise. We'll just leave it. If I want to get it a little smaller, I'll just hit it with a file or something to get it down a little bit. But I'm going to bore the gear to match that anyway, so that's close enough for tolerance wise. Cranked the speed up 1145 RPM and went to the WNMG 431 tool. A lot better finish. I think I've got rid of any vibration frequency as I was getting there. You know, I'm hearing something here now. I might have to go spin a little faster even. But looking pretty good. And a 15,000 depth of cut. I can just feel a little bit, see a little bit right in there, just hardly anything. About 1/1000 taper in the whole distance here. 559, let's see here. 5594, 5595, 86, 87. So about 1/1000 taper. So I'll try it a little faster on the next cut. A little faster, 1280. Same depth cut, 15,000. Same feed rate. Now you hear a little bit, right? Singing right there. So we have a little singing just right there. The rest looks really good. Alright, I only have about 14 thousandths to go, and I measured in the middle here where I was getting a little vibration chatter, and I'm about 1/1000th big here. So it's getting a tool push off is happening. We're getting a little flexure here. So I'm going to put this steady rest on, and we'll see how this goes. And I'm going to slow it back down. I'm 4 over. Kind of shitty finish down there. We want to clean up. But I'm going to be cutting some of this off, so. Alright, right there is 4997. That's pretty good. So. And 498. So we'll be good. We'll call that good. Like I said, we're going to put a sleeve that's going to let this slip on here anyway, and then this part's for the hand wheel and dials. So that came up. I measured the length of our shaft. I cut about 1/2 inch off, bandsaw. This chuck won't go down to, won't hold anything really smaller than 5/8. So I threw it in a 6-sided hexagon 5C collet block, threw it in the lathe. It was out about 2.5 thousandths. I redialed it in, less than 1/2 thousand run out now. Oh, that's good. That'd be, this is a short nylock nut, a thin one, and that there, that's right up to the nylon, so that's perfect. That'll be just fine. Works good because it's 1/2 inch, so I couldn't hold it back here, so I wanted to hold it tight doing those threads and stuff. So that came out really nice on the end. Now we have to put a little Woodruff key slot here for the hand wheel. And then we'll make the sleeve. Again, over from the surface plate and the V-block setup, you know, I measured out the old shaft to where the keyway sits, you know, reference from the other end of the shaft, and I scribed 2 lines for the ends of the keyway. So right there. Then we'll set this up in the vise, and we'll be able to cut that slot between those 2 lines. There we go. Perfect fit. And the nut will go on there and hold it on. We got the gear set up there, and I gripped on the gear. So I maintained, when I gripped it on the hub, it wasn't quite as good in concentricity. So I gripped it on the gear so my hole will be concentric with the gear, which is the most important. We have a 3/8 hole. We're going to open it up to 520. I have my little carbide boring bar in here. Let's see how that trued up. Yeah. So we're at 398. Go for 520 right off the bat. Oh, perfect. There. That's what I want. Perfect fit. Now it's stuck. Now for the sleeve, chunk of stock, same material as the shaft, 5/8, 4130 ground, and there we go. That's kind of what it's going to be. This slips into a bearing, and then a bushing, actually, bronze bushing rides on this part of it back here. It's not very long, a little over 3.5 inches. Had to make some adjustments because the gear is a little bit longer, so I have to fine tune the drawing. I'm about 4 thousandths out, so we'll readjust this. It just takes a second. At least that's the plan. We'll bring it back because this is a 3.5 inch hole. My 1/2 inch reamer was a piece of shit, so I reamed it at 4995, and that is just a beautiful piston fit we got going there. Just beautiful, right up to our shoulder where the gear will sit here. So I think that's we're done on the inside of the sleeve. We'll turn this outside to proper diameter and then trim to length. 590, we're at 590 and 8/10 and 375, so we'll just polish that up a little bit and get her down to the 590 and test fit it on the bearing. Okay, a little polished up, edges broke. Let's see where we're at. $590 and a 1/10. I think that's about what we're at. So we're going to test this on here. It has to fit. It comes in from this this here unit here. It comes in from this side. There's a little bronze bushing here, and then it has to fit in the bearing that's in here. Oh yeah, couldn't ask for a better fit than that. Yeah, that's perfect. So it comes in from this side here, and then into the. If I put that in there, I might not be able to get it back out. Oh, yeah, it goes. It'll go. There we go. Oh, yeah, that fits fine. I don't need to replace that yet. That'll work out just beautiful. We just got to get it to the right length. Alright, I drilled 1/8 inch roll pin all the way through like it was before. Here though, what I did is I drilled about halfway through the shaft, took some aluminum 1/8 inch welding rod, cut a small piece off, left a 1/8 of an inch up, squeezed it with a pair of diagonal cutters in a cup 2 directions, so I made it fat, pushed it in, and then peened it over like a small rivet. And if somebody wanted to press this off, they knocked the roll pin out and they press this off, it would just shear the aluminum. But that's enough to hold that stationary on the shaft, so from rotating. Just a little way to make a little shear pin and hold that in place.